Okay, so let's unpack this deep dive into, well, the mind of a chatbot. If you're like most people using tech today, you've probably talked to one, right?
Oh, absolutely. They're everywhere now.
Yeah, maybe the helpful assistant on your phone, setting a timer, or that voice on a customer service line, trying to help you out.
Or maybe you've been playing around with the newer generative AI tools, the
Yep.
really sophisticated ones.
Exactly. Drafting emails, brainstorming,
Yeah,
maybe even writing code. And they sound, well, they sound remarkably fluent, don't they?
they really do. Sometimes, honestly, it feels almost human.
Almost human. That fluency is pretty striking.
It is, and
Yeah.
it's fundamentally changed how we interact with computers. We've moved away
Mhm.
from needing, like, precise commands.
Right.
Now it feels much more like just talking, natural conversation. It's a huge shift.
It really is. And it makes you wonder what's actually going on behind that chat, under the hood.
That's the big question.
So to figure that out, we're diving deep into the specific set of sources you shared with us. There's one key document in there inside the mind of a chatbot.
Right. And our mission here really is to cut through all the noise, all the hype surrounding chatbots. These sources, they give us a pretty detailed look how these systems work, what
Mhm.
they can do, but also where they fall short.
And the ethical questions, those are huge.
Absolutely critical. So we want to pull out the most important insights, connect the dots from these different viewpoints, and give you a clear, detailed picture, but crucially one that's manageable. Kind of a shortcut to getting properly informed.
Okay. So the journey we're taking, based on these sources, we start with the core tech, right?
Hmm.
Natural language processing.
NLP, yeah, the foundation.
Then we'll peel back the layers, look at the mechanics. How do they actually process language?
The nuts and bolts of it.
From there, we get into how they learn, which is, well, it's where the power comes from, but also where the problems start.
Big problems, like
Mhm.
making things up, hallucinations and bias.
We'll look at the real world uses, sure, but also the very real limits.
Got to understand both sides.
And finally, we tackle that need for transparency, for responsible development, which brings us to explainable AI.
XAI.
Yeah, XAI is becoming super important.
So by the end of this, you should have a much richer grasp of this tech that's,
Mhm.
well, it's weaving itself into everything.
Exactly. It's a path from the basic building blocks all the way to the really big societal questions they bring up.
Okay, let's jump in. Yeah. When we talk to these chatbots, there's this powerful feeling they understand us. But the sources, they immediately bring up this idea, the illusion of understanding.
Yes. And it's a really central point. It's been relevant in AI like for decades. At the very core of all this is natural language processing, NLP. That's the branch of AI that lets machines process, interpret, and importantly, generate human language.
That's the magic ingredient, basically.
It's the bedrock, yeah. It
But-
lets them talk to us using our words, creating that perception of intelligence, that feeling of seamless conversation. Perception, that word feels really key here.
Because that's the illusion, right?
Exactly. It feels like understanding, but fundamentally, it's different. Different from how humans think.
Which brings us to the ELIZA effect. What's that about?
Ah, ELIZA. It's fascinating. It really highlights something deep about us, about human psychology. It describes our tendency, like our built-in inclination, to attribute human-like understanding, intelligence, even emotions to machines.
Even when they're not really thinking like us.
Especially when they're not. Even when they're just processing information, generating responses based on patterns they learned from data. Complex statistical patterns, sure, but still patterns.
So it's our brains filling in the gaps, projecting humanness onto them.
That's a great way to put it. Projecting human qualities onto things that aren't human just because they use language like we do.
And it's named after a pretty old program, right? Quite simple.
Yeah, ELIZA. Developed way back in 1966, Joseph Weizenbaum at MIT. It was, relatively basic. Designed to mimic a Rogerian psychotherapist.
How did it work? Super simple, really. It looked for keywords in what you typed. Then it just reflected them back, usually as a simple question or a rephrased statement.
Like mirroring.
Exactly. If you said, "My mother makes me angry," ELIZA might reply, "Tell me more about your mother." Or, "Does it please you to think about your mother?" Basic stuff.
But people felt understood,
Yeah,
even by that.
they really did. That simple trick, that linguistic mirroring, it was surprisingly good at creating this feeling, compelling even, this sense of being understood, maybe even empathy.
Wow.
Is one of the first really striking examples of how our own psychology works when we interact with something that talks. Even a simple program could trigger that anthropomorphizing tendency.
And the crazy thing is, this ELIZA effect, it's still around today. Even with like ChatGPT and Google Assistant, these super complex systems.
Absolutely. It persists. It's still a major factor in how we perceive and interact with these cutting-edge AIs. People constantly attribute real thought processes, emotions, even personalities to them.
Like saying, my chatbot's being creative today, or this AI really gets me.
Exactly those kinds of things. It shows how deep-rooted that tendency to anthropomorphize is, especially when language is involved.
So it taps into this fundamental human habit of seeing human qualities everywhere, especially in things that communicate like us.
Precisely, it's a cognitive bias.
Yeah.
And the sources point out something really mind-bending, that this simple 1960s program could basically fool people for over half a century into thinking it understood things it absolutely didn't.
That really drives home how powerful the effect is.
It really does. And it highlights a critical point the sources stress. The intelligence or understanding a user feels isn't necessarily a measure of the AI's actual technical smarts or its real cognitive abilities.
The feeling can be generated just by clever pattern matching.
Sophisticated pattern matching, yeah.
Yeah.
Not actual comprehension. And this has huge implications for managing trust, for setting realistic expectations about what AI can and can't do, and for preventing people from being misled or manipulated. This illusion of understanding, it's not just a historical anecdote. It's a real psychological and ethical challenge we have to deal with now.
We have to remember that what looks like understanding might be something very different going on underneath.
Exactly.
Okay, so humans tend to see understanding even when it's not really there, thanks to the ELIZA effect. But if they don't truly understand like we do, how do they process language so well? How do they manage that fluency? Let's get under the hood.
Right. This is where NLP gets technical. How does a machine actually handle text? NLP systems process and generate language through a structured series of steps. Core technical components, and how these have evolved shows how much better AI has gotten at handling language's complexity.
And the sources break down those first steps, right? When the AI first sees the text.
They do. The very first thing, the absolute foundation, is called tokenization.
Breaking it into smaller bits, words and stuff.
Exactly. You take a sentence, just a string of characters,
Mm.
and break it down into smaller units. Tokens, usually words, yeah, but sometimes parts of words or punctuation. These tokens are like the basic building blocks for everything else.
Got it. So the sentence becomes a list of tokens. What's next?
After tokenization, the system needs to figure out the structure. That's parsing. Parsing analyzes the grammar. How do these tokens fit together? What are the relationships between words and phrases in the sentence?
So it figures out the sentence's architecture, like nouns, verbs, objects.
Essentially, yes. Understanding how the pieces are organized grammatically, how they relate to form a proper sentence.
Okay, tokens are the bricks. Parsing figures out the wall structure. But knowing the structure isn't the same as knowing what the wall means, right?
Exactly.
Yeah.
That's the next really crucial layer, semantic analysis. This is about getting beyond just the grammar, the syntax, and figuring out the actual meaning. What's the sense, the intent, the context?
The underlying message.
Right, trying to grasp what the words and structure are trying to convey. This is tough because language is so ambiguous, right? Words mean different things in different contexts.
Definitely. So break into words, tokenization, figure out grammar, parsing, try to understand meaning, semantic analysis. How do the modern systems, the really big ones, handle this, especially with long texts?
This is where things have really leaped forward with advanced architectures, things called transformers, and crucially, self-attention mechanisms. Systems like GPT-4, they're built on this stuff.
Self-attention. That sounds like it's key for context.
It's absolutely pivotal, revolutionary, really.
Right.
It lets the model dynamically weigh the importance of each word in relation to all the other words in the input.
Not just the words next to it, but like the whole sentence or paragraph.
A whole input sequence, exactly. Think about a long sentence. The subject might be way at the beginning, the verb way at the end, or a pronoun refers back to something mentioned ages ago. Self-attention creates connections between all these words, assigning weights. It figures out the key relationships, the dependencies, the context across the entire input, not just word by word.
It's like each word gets to look at all the other words.
Yeah, and decide how important is my connection to that word for understanding the whole thing. It's a much more holistic view.
So older systems had maybe a limited window, but self-attention gives a wider perspective.
That's a good way to think about the shift. It's moved from more rigid, step-by-step processing to this more parallel, holistic understanding of relationships. It's critical for handling tricky stuff, like ambiguity or understanding connections across long distances in text. That's where the impressive fluency comes from.
Even if it's still mimicking understanding, not actually doing it.
Exactly. It's incredibly sophisticated pattern recognition, mimicking comprehension.
And how do these transformers with self-attention relate to the earlier steps like tokenization and parsing? Do they replace them?
It's more like they build on them in a layered way. Tokenization is still essential pre-processing. You need the tokens first. Now, transformers don't have separate parsing or semantic analysis boxes like older systems might have, but their ability to learn these complex patterns through self-attention effectively does the job of parsing and semantic analysis. It's all integrated.
How so?
By weighing the importance of words in context, the self-attention mechanism lets the model implicitly capture both the structure and the nuanced meaning. It learns the grammar and the semantics together in a very powerful, integrated way.
Okay, so tokenize the data, then these advanced models use self-attention across everything to pull out deep contextual meaning, all integrated.
Precisely. This layered approach is key to why modern large language models are so scalable and capable of language, why they can handle complex tasks and generate text that seems so coherent.
So these systems break down language, analyze structure, try to get meaning, use complex methods to weigh context, and this amazing ability comes from learning from just vast amounts of data.
Colossal amounts, yeah.
But as the sources really emphasize this learning process, it has some big built-in risks.
It absolutely does. That impressive fluency, that ability to sound coherent and relevant, it comes from being exposed to massive collections of text corpora.
Like reading the whole internet almost.
Conceptually, something like that.
Yeah.
On an enormous scale. And the quality and diversity of that data, the sources hammer this home, are crucial. They directly shape how well the model works, how reliable it is. But this very reliance on huge data sets, it introduces a major well-known problem: hallucinations.
Hallucinations. That's when the AI just makes stuff up.
Pretty much, yeah.
Okay.
It's a really significant, concerning issue. The AI produces information that sounds plausible, reads well, grammatically correct, but it's factually wrong, or misleading, or completely fabricated.
And the sources say this isn't just a small bug.
No, not at all.
Yeah.
It's fundamental. It stems from the training process itself, and it seriously undermines trust, especially when you need the facts to be right.
So the very thing that makes them sound good also makes them prone to inventing things. It's like a double-edged sword.
That's the critical duality, exactly. The sources point this out right away. Learning from vast data sets gives coherent responses, but that same process is the Achilles heel. It makes them prone to hallucinate.
And more data doesn't automatically mean more accuracy. It can make it worse.
Right. Scaling up data might improve fluency, cover more topics, but it doesn't guarantee factual correctness. It can actually introduce more inconsistencies, more noise for the model to potentially hallucinate from.
It sounds like a fundamental limit of how they currently work.
It really points to that. They are pattern matchers. Brilliant at finding complex statistical links in data, but they lack, built-in fact checker, a connection to the real world. Getting both coherence and factual accuracy all the time, especially on topics outside their training or when things are ambiguous, it's incredibly hard without extra checks.
What actually causes these hallucinations? Where do they originate?
The sources list a few key causes. A big one is data quality issues. If the training data is incomplete, inconsistent, inaccurate, or just not diverse enough, the model learns flawed patterns.
Garbage in, garbage out, basically.
Essentially, even a small amount of bad data in a massive data set can cause problems. And paradoxically, the sources note, some studies suggest huge, noisy data sets might make hallucinations more likely, just because there's so much conflicting information.
So quantity isn't always king. Quality matters more.
Definitely. Another cause is insufficient training processes. Using suboptimal techniques, not fine-tuning the model properly, not covering enough edge cases in the training. This can lead to the AI making stuff up when it encounters something new or unclear.
Like overfitting, learning the noise.
Yeah, overfitting is part of that. It hurts the model's ability to generalize accurately.
The sources also mention the model architecture itself.
Yes, though the focus is more on data and training, inherent limitations or specific design choices in the AI's architecture can also play a role.
So what happens in the real world when an AI hallucinates? What are the impacts?
They can be pretty serious. The obvious one is spreading misinformation and eroding trust. If an AI tells you something false, you stop trusting it. And in high-stakes areas, it gets dangerous. Imagine a medical AI hallucinating a diagnosis, or a financial AI inventing stock tips, or a legal AI making up case law.
That goes way beyond just being wrong. That's potential harm.
Absolutely. Hallucinations can also end up reinforcing bias if the fabricated stuff amplifies existing prejudices from the data, and companies face real reputational and legal risks. Look at the Air Canada case mentioned in the sources. Their chatbot hallucinated a bereavement policy. The customer relied on it, Air Canada didn't honor it, and they ended up in court, paying legal fees. Bad PR.
That's a perfect example of a direct business cost from a hallucination.
A very clear one. And there's even a worry about cyber attacks. Could malicious actors exploit known hallucination tendencies to, say, trick an AI into making bad decisions or revealing vulnerabilities?
Wow. Okay, the sources gave that really vivid example. Google's AI saying astronauts met cats on the moon and making up Neil Armstrong quotes. How does that show the pattern matching limitation?
That example is fantastic, actually, because the AI doesn't know humans didn't meet cats on the moon, not like we do, with common sense. Instead, it's seen patterns. It's seen text about space, astronauts, moon, and maybe separate text or images about cats. When you ask it something that vaguely connects these, its pattern matcher might think, statistically, combining these concepts seems plausible based on correlations in my data.
Even if it makes no real-world sense.
Exactly. It's combining things based on statistical likelihood from the training data, totally disconnected from verifiable truth or physics. The creativity is just sophisticated statistical guesswork without a reality check.
So the fluency is impressive, but it's a side effect of pattern matching that doesn't have built-in truth validation.
Precisely. Its ability to generate novel text isn't human-like creativity. It's complex correlation that can sometimes lead it to confidently invent nonsense when the data patterns are weak or conflicting.
And the sources draw a strong line connecting hallucinations and bias, saying they often come from the same place.
Yes, this is a really important connection they make. When talking about hallucinations, the sources keep mentioning things like data quality issues, lack of diversity, inconsistencies. And when discussing bias, they point straight at reliance on training data and perpetuation of biases present in that data. The root cause is often the same: problems with the training data itself.
Okay, so hallucinations happen when the AI tries to fill gaps or make sense of noisy data using flawed patterns.
Right, and bias is more of a direct reflection of the societal prejudices already baked into that data.
So cleaning up the data, making it higher quality, more diverse, that helps fight both problems.
Absolutely. It makes data curation, governance, ongoing auditing, makes them crucial ethical and technical challenges. If the data is flawed, the AI will be flawed, often in harmful ways.
Are there ways to, reduce hallucinations, make these systems more factual?
Yes, definitely. The sources talk about several techniques. One really interesting one is retrieval augmented generation, or RAG.
RAG, how does that work?
Okay, so RAG basically connects the language model to external, reliable knowledge sources, like databases, verified documents. Instead of only relying on what it learned during training, the AI can actually look up information in these trusted sources before it answers you.
Like giving it a fact checker it can use in real time.
Exactly. It retrieves accurate, current info from these sources and uses that to ground its response. It really helps improve factual accuracy. Great for things needing specific knowledge, like legal citations or product details.
So it anchors the AI's answer in something verifiable.
Precisely. It's effective, though the sources note it's not foolproof. The quality of the external sources matters, and the AI still has to interpret the info. Another big strategy is prompt engineering. This is about how you, the user, interact with the AI.
How you ask the question makes a difference.
A huge difference. Being really specific in your prompt, giving details, context, constraints. That helps a lot. Using chain of thought prompting for complex things helps too. You ask the AI to break down its reasoning, step by step. Makes it less likely to jump to a wrong conclusion.
Like showing its work.
Exactly. Also, limiting the possible outcomes in your prompt, giving examples of what you want, that can guide it. And importantly, asking the AI to cite its references. Then you can check them yourself.
Those are things the user can actually do. That's empowering.
It is. Other things mentioned. Obviously, starting with the best possible high-quality training data is fundamental. Setting clear objectives for the AI model during development helps keep it focused. Using data templates can guide the output into expected formats. And of course, regular testing and refinement. Finding hallucinations and fixing them is an ongoing job.
Okay, so hallucinations are a big issue coming from the data. And you said bias is another, maybe even more insidious problem rooted in that same data. Let's dive into that ethical minefield.
Yeah, AI bias it's a critical ethical challenge. The sources define it very clearly. It's not just random mistakes. It's when algorithms consistently produce systematically prejudiced or unfair results.
Systematically, meaning it's a repeatable pattern of unfairness.
Exactly. Consistent, repeatable discrimination, often against certain groups. Not just bad luck. Understanding that systematic nature is key.
Where does this systematic bias actually come from in an AI?
The sources point to several interconnected sources. One is algorithmic bias itself. Sometimes the way the algorithm is designed or trained unintentionally favors certain groups. Like maybe it learns to weigh factors that reflect historical discrimination, even if nobody meant for it to do that. This is really worrying in areas like hiring, loans, criminal justice.
So the math itself can become biased based on the patterns it finds.
It can, or how it's told to find patterns.
Yeah.
But a huge, maybe the biggest source is data bias. AI learns from data. If that data isn't representative or if it reflects existing societal biases, the AI learns those biases.
Like if the data itself is skewed.
Exactly. And data bias has different flavors. There's selection bias. Some groups are just underrepresented in the training data. Train facial recognition mostly on one group, it won't work well for others. There's labeling bias. This comes from the humans who label the data. Their unconscious biases can creep into the labels. Maybe they label certain resumes as better fits based on gender stereotypes. And sampling bias, the data collected just doesn't accurately mirror the real world.
So if the data reflects a biased world, the AI becomes a biased mirror.
A bias mirror that can then amplify those biases,
Yeah.
Which leads to the next source. Human bias in AI development. The people building these systems, we have biases. And those can unintentionally get baked into the AI through choices about data, features, how success is measured.
Even with good intentions.
Absolutely.
Right.
It's hard to escape your own perspective. That's why diverse teams are so important. And finally, there's bias in model training and deployment. Train on biased data, get biased results. And if you deploy a biased system without checks, without updates, it just reinforces and scales up inequality.
What are the actual effects of this? How does AI bias hurt people?
The impacts are severe. It leads to systemic discrimination, biased hiring tools, screening out qualified candidates, unfair loan denials, predictive policing targeting certain neighborhoods, biased healthcare tools leading to worse outcomes for some groups.
These are real-life consequences, affecting jobs, money, justice, health.
Directly. It also contributes to reinforcing harmful stereotypes, like AI image generators showing only men in certain jobs or associating groups with negative traits, like hallucinations. Bias causes misinformation and erodes trust, and companies face major legal and reputational risks, lawsuits, bad press.
And the sources mention something really worrying, how biased AI can make humans more biased.
Yes, this is critical and quite disturbing. When people rely on biased AI advice, especially under pressure, they can start making more discriminatory decisions themselves, even if they normally wouldn't. The MIT CAL example they cite is stark. People using biased AI for urgent tasks became more discriminatory than those without the AI.
So the AI isn't just reflecting bias, it's actively nudging humans towards it, amplifying it.
Precisely. Which makes tackling AI bias not just a tech problem, but a deep ethical and societal necessity. Its systematic nature means it can cause widespread harm if we don't address it proactively. We have a responsibility to prevent that.
The sources included that table too with concrete examples. Those really bring it home.
Yeah, that table is crucial. It makes it tangible. Amazon's recruiting tool biased against women. AI image generators reinforcing gender stereotypes in STEM. MIT's risk prediction algorithms leading to discriminatory human choices.
Google's ad system showing high-paying jobs more to men.
Right. HireVue's video analysis discriminating against non-standard speech. Facial recognition failing more often on darker skin, leading to potential wrongful arrests.
These examples make it impossible to ignore. You see the direct line from the bias system to real-world harm, makes mitigation feel urgent.
Exactly. It connects the abstract concept to concrete discrimination, damage, and inequality across different sectors.
So how do we mitigate it? Is there a magic fix?
No, definitely no magic fix. The sources are clear. It requires a holistic, multi-layered approach. It's not just tech. It's governance, diverse teams, constant vigilance, the whole life cycle.
A multi-layered approach. What does that look like in practice?
Okay, so several strategies need to work together. First, bias mitigation techniques during development. A really key one is rebalancing training data, actively curating diverse representative data sets. Maybe using techniques like data augmentation to create more examples for underrepresented groups, or reweighting samples during training. Fixing the data source is fundamental.
Makes sense. Attack the root cause.
Exactly. Then there's adversarial debiasing. This is like training the AI specifically not to be biased. One part of the system tries to detect bias, another part tries to fool the detector. Also, differential privacy helps reduce bias from exposing sensitive data patterns. And federated learning, training models on local data without centralizing it, can help leverage diverse data while protecting privacy.
So technical fixes apply to the data and the training? What about people?
Human oversight is absolutely paramount, especially for high-stakes decisions. AI should augment human judgment, not replace it. We need human-in-the-loop systems where people review and can override AI decisions at critical points. And for that oversight to work, we need transparency. Which brings us back to explainable AI, XAI. It helps humans understand why the AI decided something so they can spot bias.
And the people building the AI matter too, you said?
Absolutely. Diverse and inclusive AI teams are crucial. Different perspectives are much better at spotting potential biases early on. Inclusive design, testing with diverse users. It all helps.
More viewpoints catch more blind spots.
Exactly. And finally, third-party audits and continuous monitoring. Fairness isn't a one-time check. You need independent audits to find hidden biases, and you need to keep monitoring deployed systems because bias can creep in or change over time. Real-time monitoring can flag problems for action.
It's clear mitigating bias needs effort across the board. Data, tech, people, process, ongoing checks. And like you said, for human oversight to really work, you need to see why the AI did what it did. Which leads us straight to explainable AI, XAI.
Precisely. XAI tackles the black box problem head-on. As AI gets more complex, especially deep learning, and gets used in really critical areas, healthcare, finance, self-driving cars, their decision-making often becomes opaque.
Input goes in, output comes out, but the middle is a mystery.
Exactly. And that mystery makes it hard to trust, hard to fix when it's wrong, hard to hold anyone accountable. XAI is the field trying to fix that, developing ways to make AI predictions and actions understandable to humans.
Opening up the black box, basically, or at least showing its reasoning.
Right. And doing it in a way that builds confidence, allows responsible use, allows scrutiny. The sources frame XAI as more than just a nice-to-have. It's fundamental for responsible deployment in sensitive areas. Without transparency, using AI for critical stuff hits trust barriers, regulatory hurdles. XAI directly helps address ethical worries like hallucinations and bias by making decisions auditable, understandable. It's key for building trust and aligning AI with human values.
So XAI is crucial for trust and responsible use. What are the specific benefits?
The sources list several. One big one is better decision-making. If you understand why the AI recommends something, you can make a more informed choice. Like if XAI shows why an AI thinks a customer might leave, the business can act on those specific reasons. Another is faster AI optimization. If an AI messes up, XAI helps you figure out why. Much easier to debug and improve than staring at a black box.
Helps the developers and engineers.
Definitely. And hugely important, increased trust and reduced bias. XAI reveals the patterns the AI found, lets you trace the reasoning, spot errors, check for bias, vital for trustworthy, human-aligned AI. If you see the reasoning, you can trust it more easily. Or challenge it if it looks wrong.
Which leads to more people actually using it.
Right, higher adoption. As trust grows, adoption follows. And finally, ensured regulatory compliance. More and more laws require AI decisions, especially those affecting people, to be explainable and auditable. XAI provides that capability.
Okay, the benefits are clear. Trust, debugging, compliance. But making AI explainable sounds hard. What are the challenges?
It is challenging. One issue is complexity. Sometimes the explanation itself can be really complex, hard even for experts to grasp fully. Another is verification. How do you know the explanation is actually correct and complete? Is it truly showing how the black box worked, or just a plausible story? Generating explanations can also be computationally intensive, especially for big models. Hard to scale.
And the sources mentioned a basic tension, a trade-off within AI itself.
Yes, a really fundamental one. The trade-off between accuracy and interpretability. Often the AI models that perform best, the most accurate ones like deep neural networks, are the most complex and hardest to interpret. They're the black boxes. Simpler models like decision trees are easier to understand white boxes, but might not be as accurate on complex problems.
So you often have to choose between top performance and easy understanding.
That's often the dilemma. It means XAI research is working on two fronts: finding better ways to explain existing black boxes, post hoc methods, and also developing new types of AI that are powerful and more inherently understandable from the start, white box methods, or just better ways to present the explanations.
Which ties into another key point from the sources: tailoring the explanation to who needs it. The audience matters.
Hugely important. Critically important. There's no single best explanation. What works depends on the model, the situation, and who is asking.
A data scientist needs something different than a doctor using an AI diagnosis tool or a patient getting that diagnosis.
Totally different needs. A good explanation for an engineer debugging code is useless jargon to a business leader making a strategy call or a regulator checking for fairness. Effective XAI needs user-centered design, clear, actionable insights tailored for different people.
The sources also gave some ways to categorize XAI approaches.
Yeah, conceptual frameworks. One is global versus local. Global XAI explains the model's overall behavior, like which features are generally most important. Local XAI explains one specific decision. Why was this loan application denied?
Okay, big picture versus specific instance.
Right. Another is direct versus post hoc. Direct XAI uses models that are inherently interpretable, white boxes like decision trees. You can just look at them and see the logic. Post hoc XAI applies explanation techniques after the fact to complex black box models like neural networks.
And the last one.
Data versus model XAI. Data XAI explains based on input features and relationships how changes in input affect output. Model XAI explains based on the model's internal workings, like looking at neuron activation patterns.
And they mentioned specific techniques. LIME and SAP were named.
Yes, two prominent ones. LIME stands for Local Interpretable Model Agnostic Explanations. Model agnostic means it works on any black box. For one specific prediction, LIME basically builds a simple, understandable model that approximates the black box just in that local area.
Like a mini explanation for one decision.
Exactly, a local approximation. S-shaped Shapley additive explanations uses game theory concepts, Shapley values, to assign credit for the prediction to each input feature. You can give both local and global explanations. It's theoretically strong good fairness properties, but can be computationally heavy. Other techniques exist too, like inherently simple decision trees, various visualizations, and counterfactual explanations that ask what input change would flip the decision.
Where's XAI actually being used now, especially in those sensitive fields?
It's becoming vital. In healthcare, explaining image analysis why an AI sees a tumor, helping doctors trust and verify AI findings. The sources mention a LIME study boosting skin cancer diagnosis accuracy by 15% when used with radiologists.
That's a concrete benefit right there.
A powerful example of human-AI teamwork via XAI. In finance, it's crucial for compliance, explaining credit score decisions why denied, for fairness and regulation, explaining fraud alerts. A SHAPE study mentioned reduced loan denials by 20% because the explanations allowed for better understanding.
And then things like self-driving cars, autonomous systems.
Absolutely critical for safety and trust there. Understanding why the car braked or swerved. Essential for debugging, improvement, and getting people to accept the technology. Regulatory bodies will demand it.
Okay, so XAI helps us understand how AI decides things, which is key for tackling bias, building trust, enabling oversight, and deploying AI responsibly. This seems to bring us to the bigger picture, the future relationship between humans and AI.
Right. We started with that paradox, didn't we? Chatbots sound human, but lack real understanding, the ELIZA effect.
And the way the sources and our conversation unfolded, it feels like it mirrors how the AI field itself is evolving.
It really does seem to. Starting with capabilities, then uncovering flaws like hallucinations and bias as things got more complex, then needing solutions like XAI and ethics. It's like a maturation cycle.
From just focusing on performance to grappling with the consequences.
Exactly. The field is moving beyond just pure tech specs to dealing with the deep ethical, social, even psychological impacts. Future progress isn't just about more power or data. It's about ethical frameworks, responsibility, managing harm.
And throughout, we keep coming back to that basic tension.
Between AI operating by analyzing patterns and predicting responses, and us humans expecting genuine understanding. AI's limits nuance, emotion, common sense, ethics. These are human strengths. It shows a fundamental difference.
AI is doing sophisticated pattern matching, not human-like thinking.
Precisely. It simulates understanding, but the mechanism is different. We have to keep that in mind, be aware of the limits, avoid over-reliance. And as we saw, tackling bias and hallucinations isn't just technical debugging. It's a deep ethical imperative. Requires that whole multi-layered approach.
And XAI is a vital tool in that mission.
Essential. For transparency, trust, compliance, making the black box understandable, auditable. It lets us build AI we can trust, that aligns with our values, that we can oversee effectively.
So pulling all this together, the power, the limits, the risks, the solutions, what's the big takeaway about AI's future role?
The sources point strongly in one direction. The future isn't about AI replacing human intelligence. It's about strategic augmentation.
Augmentation, not replacement.
Exactly. Current AI just lacks too much causal reasoning, common sense, emotional depth, ethical grounding. The goal isn't to replicate humans, but to leverage AI's strengths, analyzing data, finding patterns while we provide the oversight, the ethics, the context, the judgment, especially for complex decisions.
A human-AI collaboration.
That's the vision. A synergy where AI handles the heavy lifting on data and humans handle the strategy, ethics, creativity, empathy, the uniquely human stuff.
So our roles evolve, they don't vanish.
Precisely. AI frees us up to focus on what we do best. Human intelligence is way broader than machine reasoning. AI is a tool, an augmenter, not a substitute for us.
It reframes it as collaboration, not competition, emphasizing what humans uniquely bring.
Exactly. And ultimately, understanding how these chatbots work, their strengths and their weaknesses, risks, and the tools like XAI to manage them is just fundamental. We need that balanced view to use this powerful technology responsibly and beneficially.
This has been incredibly illuminating, really getting inside the mind, or maybe the mechanism of the chatbot. Thanks for walking us through these sources.
My pleasure. It's crucial stuff to understand as AI becomes more pervasive.
And as we wrap up this deep dive, let's leave you, our listener, with something to chew on, drawn right from the heart of what we discussed. Given that AI's impressive fluency comes from complex statistics, not real understanding, and given our powerful human tendency to project understanding onto it, that ELIZA effect, how do we individually and collectively navigate that gap? How do we build trust where it's warranted, maintain skepticism where it's needed, and ensure AI serves us ethically, especially when it's involved in the most critical points of our lives? Something to really think about.